want them without all these long spaces in between. So you just do like a little symbol character, and everything just gets formatted. Alright, so I'm running it here, and we'll see that the name was going to be Joe, but everything else is going to be garbage. There you go. Oh, I guess negative, since it's a float, it's just going to be negative 1 point whatever to the e. So a very big number. So we're going to be moving that decimal place to the right by 8. Yeah, some negative big number. Okay. So whenever I'm done talking. Okay. So now I'm gonna change the constructor and actually put some values instead of position X, Y, and lives to show you that it's a good idea to initialize those values. And I'll show you 2 ways of doing this. The first way is a regular old way where you, instead of that body of that function, you just, assign them as you would or as usual in any other place. So now we can see that everything is zeroed out. Good. We don't have any garbage data. Everything looks good. And the second type of initialization is called a initializer list. This is newer in C++. I don't remember what version it is, but you can search for it if you want. So you put a colon in front of your constructor, and you put the variable names followed by a it's kind of like calling a constructor for those variables, and then a comma separate values, and inside those parentheses you would add whatever value you want them to start at. So that's another way of using or of initializing your data. Now the last one should not have a comma. There you go. And if you, well, I think I'm going to change this to 10 so you can see the difference. And voila, it's the same thing. I think, I don't know which one's better or which one's faster or whatever, but you can use whichever one you want. I tend to use, if I'm passing data in, I tend to use the initializer list, and if I'm not passing any data in, I'm probably using the other one. So yeah. Alright, so what am I going to talk about? Oh yeah, the type def stuff. I think we already covered that. Okay, it looks like I obliterated everything, and I'm gonna delete all this stuff, and I will talk well, in the video, I was going to talk about public, protected, and stuff like that. I guess I can do that again. Because there's actually some differences between public, protected, and private, and when you would use those and what the difference is between those. And I guess I'll just wait and see until I start typing it to explain it. I don't know what I'm saying right now. Can't read my lips. Why am I doing all that? I don't know. Alright, there we go. So public. I don't know what they're called exactly, but as we know, structs and their data are public. So what does that mean? What does that really mean? Well, when we say that data is public, that means it is public to the outside world, outside of this structure. When we're calling functionality for this object, that is where this applies to. So if we want people to access outside of this class those variables, we would put it under public, and I'll show you an example of this right now. So notice that everything is in protected right now, and I'm going to make an instance of this class. Right? And then I'm going to try to access any information. Notice that it doesn't populate anything, right? Well, why is that? And I'll show you why. So let's get one of these variables up into the public section of this code. And now when I try to access anything, only name shows up. And that's what I was talking about right there. Notice that name is the only public variable right there. That's why we can access outside of this function, of this class. So if everything else is protected, you cannot access. So why do we want to do this? In some cases, you want to do this for like sensitive data that does not need to be, that they're trying to protect it against being modified directly. And what does that mean? Well, when you say that you want to modify something directly, you get that variable. But since you can't get that variable, you need to change that data in a different way. One, you can get this class itself, change that data itself. If you want to set it to something else, you would need to do a helper function. It's usually called a mutator when you do a getter. A setter, not a getter, because it mutates the data. It changes it in a particular way. And we'll show an example of that right now. So everything we have right now is in private. You cannot access outside of this class. I'm going to make a function or a mutator or a setter to do this, to change that data. And I think we're going to change the name to something else. And right now, I guess I'm explaining what private and protected are. So private, it's, you cannot access it outside of the class, and you cannot access it on your child members or friend classes. Protected, child members can access this data, outside world cannot access this data. Public, anybody can access this data. So that's pretty much all it is doing. All right, let's go ahead and create that set name function. Anytime now. So slow. I might just fast forward to this, maybe. I'll probably do that. I think this thing is like, we're barely 30 minutes in, and still go. I mean, we still have like 20 more minutes to go, because like 50 some. There we go. Alright, so this is a setter function. The reason why it's called a setter is because it allows us to set the data to something else. Or it's also called a mutator because it mutates the data and changes it to something else. Now, if we just do it like this, how I just did it, it defeats the purpose of having it private or protected, because you're just setting it indirectly but directly to it. You know what I mean? You're not checking for like any special things, like is this string an empty string? Okay, we don't want to change it if it doesn't have anything inside of it. Or how many characters are inside of this? If it's less than a certain amount of characters, then we don't want to change it. We'll want to give an error or something. And this is what I'm going to do. Another example of that would be, let's say that we're checking to see if it has all the maximum number of characters, or the minimum, a little bit over the minimum number of characters, but we don't know if they just put spaces, so we would have to check that too. Alright, so right here it should actually be new name.size is greater or equal to 2, because there are names where you only have 2 characters or 3, like Asian. I think Asian people have like 2 or 3 character names. Dan, D-A-N, that's a 3 character name. So yeah, and here we're comparing. We're actually not going to use new name.compare. We're going to be using a different function called strcmp, or string compare. And the way that function works is you give it two strings to compare. So in this case, it's going to be the spaces and the new name. It takes a char pointer, and what this function does is if things like if the right one is greater than the left one, it's going to be 1. If the left one is greater than the right one, it's going to be -1. But if they're both equal, it's going to be 0. And here is how you do that. So if it's equal to 0, that means if they're the same. And to convert a string to a char character, or char pointer, not char character, because char is character. Duh. If you want to compare, change it to a char pointer, you do .c_str. So here we're going to be saying, okay, if If those two statements fail, we're just going to print out that error, that we don't have a valid name. Size is actually a function. There you go. Run it again. So you see there that we get an error. And it's not a valid name. And if we pass spaces, it says it's another error. And if we pass MP, it's still going to give us an error because it's greater than 2, not. It has to be currently, it has to be greater than 2. And there you go. Okay, so that's how you would use imitator or etc. Alright, so onto classes. Now, let's make a class and we'll call it object. Okay, so by default for classes, everything is private. So if you want to have something public, you better put that public thing in there. Otherwise, you will not see it. And here's where I'm going to show you how the constructor and destructor work. Okay. And I'm not going to pass any parameters to it. I'm just going to print out something that lets us know that this got executed. It says the constructor, and then we're going to do the destructor. And okay, so if the constructor is called whenever you give life to this object or instantiate it, the destructor would get called whenever you destroy this object. Now, something to note is what I'm about to show you. This object, if it's not created on the heap, it's going to get destroyed at the end of the scope of whatever instantiated it. So if you create something on the stack, an instance, not a pointer, on the stack, if you create an instance of an object on the stack in the main function, it's going to be persistent until you exit of that main function. Okay? Now it cannot be called within other functions unless you pass it in. But it will not get deleted until that you exit out from that main function. And here's where I show you. And I will go step by step. Now I'm gonna press a key and notice that you didn't see the destructor at all while I'm still running. Come on. Press enter or something. There you go. You didn't see the destructor fired at all. And why is this? Well, we don't get out of that function till line 36. So, as you can see, once we actually go there, and return, you will see what the destructor has to say about it. See? Now you can see that it is deleting this object. This is calling the destructor. And there you go. It called it right at the return line. That's when you're exiting your program. Now, what if we didn't want it to be like that? What if we just wanted it to exit where's right before system pause, right after we instantiated it? Well, you can do something like that, but you have to use the heap for that, because you cannot control how something is created and destroyed. Well, I guess you can when something is created, because you just make a variable for it, but you cannot dictate when something gets out of memory or is thrown out of the memory in the stack. I don't think, at least. So you'll just have to wait until everything gets hopefully called. Well, I'm sure it'll get called, but yeah, at the end of your function. I'm going to be instantiating here with the new keyword. We talked about this in the pointer section. We're going to be instantiating an object instance, and this object instance is going to be calling the constructor again, but once we delete it, it's going to call the destructor right before system pause, and you'll see the difference. Also remember, whenever you use delete, when you're using pointers, make sure you always check to see if the pointer is not null. If you fail to check that, and if it's null, and if you try to access it or delete it or do anything with it, you're gonna crash. So please, please, please remember, always check your objects, your pointers. Make sure they're not null before you use it. Alright. So here we're going to be making a macro function, and I'm going to be making a safe delete function that will take in any pointer. We'll check to see if it's valid, if it has any data in it. And if it does, it's going to delete it. And the reason why I'm making this and not a function, a regular function, the reason why I'm making a macro is because when you do functions like these, you don't need to pass a certain type of object. You can just pass any. If we had a class called, I don't know, chocolate, we can pass it through there with no problem. We don't even have to typecast. And that is very powerful, very cool, and I love that feature. It sucks that you can't do it in C#. That's why I don't like programming in Unity that much, or C#. It's just, I feel so limited. It's like, I miss pointers. I miss everything about C++ whenever I'm in C#. And then when I'm in C++, I'm like, oh my god, why? But I mean, it's complicated but fun at the same time, for me at least. And here you can see that the constructor was called, and then right after that, since we deleted that object, the destructor was called, and we pressed, and it was before the system pause. Alright, we're almost done. We got about a couple seconds left, actually. Alright, guys, thank you for watching this tutorial. Hopefully you guys learned something about classes, and let me know if this helped you guys. And if you guys have any comments, questions, concerns, don't hesitate to subscribe. But if you liked it and you learned something from it, subscribe and you'll get more. See you. Have a great day.